My name is Irvin Meneses, and this is the Water Valve Project. Water Valve Project. Alright, I'm gonna do it again now. So this is demo one. So demo one is basically having both water valves open for a certain time interval. So in this case, for 10 seconds. Sweet. That was demo one. Demo two. Demo two, when I ask the user for input and say whether he wants to open one or two valves. So in this case, let's start off by only opening one. Two valves, I select one, and then it would ask you for how many seconds. Let's say another 10 seconds. So you can see the black one open, so we can also reverse this role. So in this case, I can change my program and have the green one open. Another 10 seconds. Hey guys, now I'm going to be talking about my experimental setup. As you can see, we have a knob which controls our main water source. When open, water then travels through this water hose, which then leads it into our flow meter. Once it passes the flow meter, water travels through this white pipe, which then feeds water into both of my valves. As you can see, my black valve has two red wires and my green valve has two black wires. In order to connect both of my water valves to my microcontroller, I used a multi-strand wire. As you can see, one wire from each valve got connected to the white end of my multi-strand. The remaining black wire from my green valve got connected to the green end, and the remaining red wire from my black valve got connected to the red end. The multi-strand wire then leads into my microcontroller. As you can see, the black relay controls the black valve and the yellow relay controls the green valve. These red caps represent the ends of my 24 VAC signal, which you can see here. This connection here provides the 9 BDC signal needed in order to power my microcontroller. This USB port here is needed in order to communicate with your microcontroller. Here is an image that shows how I wired the yellow relay. This image shows how I wired the black relay. This image shows how the previous two schematics would look when wired to a circuit board. Here's an image of a program I wrote using MATLAB. The program will ask the user for a flow rate. The flow rate is assumed to be in gallons per minute. Once the user enters a flow rate, the program will ask the user for a time interval. Once both variables are defined, the program will calculate the amount of gallons that was released during that time interval. Here is an image of a program I wrote using the basic step editor. The program asks the user for how long he or she would like the valves to be open. Once the user enters a time value, the microcontroller will send a signal to the relay, which closes the switch and allows the 24 VAC signal to get to our valve. In this program, the user will have to input the number of valves he or she would like to have opened. Once this number is defined, the program will ask for a time value. Once both of these variables are defined, the microcontroller will open the number of valves the user requested. In this image, you see a circuit which integrates a flow meter with my basic stat microcontroller, as well as a program which will allow my microcontroller to receive and count the number of pulses it receives from the flow meter. The flow meter sends 151 pulses for every gallon. With that being said, if this were to work, we would be able to integrate this circuit to our previous two valve programs, which will allow the user to have complete control of the valve's water output. This would be done by writing a program which will ask the user how many gallons he or she would like the valves to release. Once the user enters a value in gallons, the program will convert the user's input into a number of pulses. Once we get the number of pulses, we would write a for loop with conditional statements in it, which will monitor the number of pulses and determine whether the valve should be open or not. If the number of pulses is below the user's input, then the valves will continue to be open. Once the microcontroller receives the number of pulses the user requested, the valves will be closed. This was supposed to be demo 3, but unfortunately, after testing this program along with the circuit, I wasn't able to get my microcontroller to receive or count any pulses. With that being said, this leaves room for future interns to tackle this problem. As stated previously, the only issue I had was being able to get my microcontroller to receive pulse signals from the flow meter. I believe that once solving this problem, I will be able to continue and finish this project.